So, pretty much 1 or 2 questions on your test is a day 2 question. And 75% of your questions on your test coming up is from today, okay? Because the tricky part of polar graphs is what we're about to experience. What happens when our radius is negative? If I were to sketch the graph of r equals -2 from 0 to pi over 2, here's what we have to understand. My angles are the angles between 0 and pi over 2. We are used to our graph existing in this quadrant where my angles are between 0 and pi over 2. But that's not happening here. Because when my angle is 0, my radius is -2. That means I got this point that I'm starting with. This is my start. I start there. As my angles increase from 0 to pi over 2, this is my graph, but as my angles, think about your terminal rays. As your terminal rays are increasing, your graph is plotted in the 3rd quadrant when the radius is negative. We will be traveling in this direction until we end at this point at pi over 2 with a radius of -2. Does this make sense? Okay, well, let's see. Go to your homework and do a couple for me. Do this one, please, and this one. Thanks, Ire. Welcome, welcome. We literally have like 18 people tell me on the way in. Linda was having a nice conversation. It's like, yo, what's going on here? Let's not. Hey, how about this? Let's copy Cole Trickett's homework at the beginning of next class in front of our teacher. This is on YouTube, by the way. I'm just dropping names left and right. Well, batting 1,000, Woods. I'm glad you're here. If we are talking about the angles between pi over 2 and pi, give me a start and an end in a direction. I would talk about a start here. At that point, I would be increasing my angle, but my radius being negative would put my graph over there. We would end there. Got it? How do we do on that? Great, do the next one. Some of us bad. I want to start and an end in a direction. Pi over 3 to 2 pi over 3. Our angles here. However, pi over 3, we want to plot a radius of -4, somewhere around there. Pi over 2, we'll plot a radius of -4, somewhere right there. 2 pi over 3 will plot a radius of -4, somewhere over here. This is my start. This is my direction. This is my end. If we talked about increasing our angle. Very important. It is not what we're used to. It's a little bit different. Now go back to the notes. Some of the other ones on this front page are just tricky. If you don't understand it, it's okay. And let's look at this guy. Please sketch the rectangular form over here on the left to y equals 1 plus 2 cos theta. While you do it, I'll do it. Do y equals 1 plus 2 cos x, and then we will look at what that looks like on the polar graph. See if you guys can get it. Stop copying down and do it yourself. You don't learn when you copy. You learn when you do. You don't get good. You don't get here by wishing. That's close. That's Pete Maravich. That's a good one. John Wood. Look, I got 2 basketball guys up there. Pistol Pete, man. You don't even know Pistol Pete?
Where? Oh, I can see that one.
Okay. Midline 1, amplitude of 2. Step of pi over 2. Max, midline, min, midline, max. What is different about this than we're used to? Hey neighbors, what's different about this rectangular graph that we haven't seen on the day 2 homework? What is going on here that you didn't see on the day 2 homework? Thank you. We get into the land of negative radii. Now, can you just pump the brakes thing? You know, you don't help anybody out. Now, there's a very important number, and that is a radius of 0. Radius of 0 means we're at the origin. We are about to be asked questions about moving toward or away from the origin. Well, let's make sure we understand the origin is radius equals 0. Cool. So maybe we should spend a little bit of time finding when my radius equals 0. No, not at pi. No, not 3 pi over 4. You're just guessing. 2 pi over 3. 4 pi over 3. Remember, we talked about the pi over 3 being important because they're the values that give us a half of our amplitude. So it's not pi over 4. It's 2 pi over 3 and 4 pi over 3. But let's go and include all the pi over 3s, but 2 pi over 3 and 4 pi over 3 are very important points where my radius crosses through this equals 0 horizon. Okay, now I just want us to read this question and try to answer it based on what you see, not looking at the polar graph. A lot, guys, of this third lesson is not about sketching.
It's decreasing away from the origin.
Toward or away?
Away.
Is the graph moving toward or away from the origin? We know r equals 0 no matter what my angle is. When r equals 0, you are at the origin. So tell me, is our graph moving toward or away? How about this? Is the distance between the origin and the graph increasing or decreasing? That's most of your questions.
I think, wait, was that the question on the last list? Yeah.
No, it wasn't, because this is different. Guys, we are moving away from the origin. the distance is increasing. Why? And what does that look like? So like Woods, I like to make fun of you a lot, but you're nailing it right now. For the first time ever during a lesson, you're nailing it. Guys, shh. No, he's not. I know, exactly. It's always after he cheats, he's locked in. When think about radiuses. When radiuses are getting closer to 0, we are going to be going towards the origin. Let's look at this graph of 1 plus 2 cos theta. Okay, start over. Stop. Okay. All right, ready? Look at your rectangular graph. We can look at it together. We have a radius of 3 until 2 pi over 3 when our radius is 0, right? Here we go. Between the angle of 0 and the angle of 2 pi over 3, our radius is going to decrease. Let's see what that looks like. Here is my graph getting closer to the origin. Bam. You saw this on your quiz. Like how you got all the way to the angle of 2 pi over 3. Here's the angle of 2 pi over 3, and I got a 0. Between 2 pi over 3 and 4 pi over 3, my radius is negative. My radius goes from 0 to -1 and then back to 0. Let's see how between these two angles, my radius is over here. We got pi. We are at -1. Between 2 pi over 3 and pi, we can see, Ford, that we're going away from the origin. But then from pi to 4 pi over 3, we're going back towards the origin. And now we get to, I'm a little bit off here. Now we get to this angle 4 pi over 3 where we have another 0. We are back at the origin when r is 0. This is very important, guys. What do you mean? This is the angle 2 pi over 3. The angle 2 pi over 3 is when, why do I have to shade? Because drawing lines are tough on this thing.
Why do you draw a line?
Because that's when my radius is 0. At 2 pi over 3, my radius is 0. I'm at the origin. At 4 pi over 3, my radius is 0. I'm at the origin. That point right there is 4 pi over 3. At 2 pi over 3, my radius is 0. At 4 pi over 3, my radius is 0. In between, I had a negative radius. So even though my angles are here, just like when we were graphing r equals -2, my graph's over there. Then, from 4 pi over 3 to 2 pi, I have that positive radius going out. This is the graph. This is different. We have an inner loop. What's the inner loop from? Negative radiuses. Not always will inner loops be from negative radiuses, but understanding why is the graph like this is important.
How do you know that the radius is 0?
Because we asked when will this equal 0? And we solved this equation. We found that, it's like half of my amplitude, which is 2, will give me 1 or -1. This is the idea of, hey, at pi over 3, I'd have 2. At 2 pi over 3, I'd have 0. Or I solve this equation, 1 plus 2 cos theta equals 0. R equals 0 means we're at the origin. It's important to know when we're at the origin so we can know if we're going towards or away from the origin. Got it?
Yeah.
Or if our distance is increasing or decreasing. I hate when this happens. Is next unit easier or harder? Different? So, next question. From pi to 4 pi over 3. Answer it. From pi to 4 pi over 3. Answer the question. We are moving toward the origin. The distance is decreasing. Go to your homework. You guys are complaining about the homework. Well, go to your homework. Maybe we can get some homework done. Why does this happen all the time? Next question. Go. This is on your homework. It's on the third page. What? All of these intervals, you're going to tell me whether the distance between the graph and the origin is decreasing or increasing. We know r equals 0 is when your graph is going to be at the origin. If we are getting closer to 0, we are getting closer to the origin. If we are getting further away from 0, we are getting further away from the origin. It's closer to pi over 2 than it is to pi. It's 60 degrees away from pi. It's 30 degrees away from pi over 2. Increasing or decreasing? That's the question. For all of these. There is one question where it is both. This should be 4 pi over 3. But no, I don't think it's both. It's not both. For each interval, the answer is either increasing or decreasing. No, for each interval, the answer is either increasing, the graph is going away from the origin, or decreasing, the graph is going toward the origin. This one needs to be a 4 pi to 4. And this should be 5 pi over 3. Yeah, I'm sorry. That one, yeah, okay. I don't know why I kept copying over like that.
2 pi over 3 pi is also.
No. Okay, we're going up to 9. We go down to -3. 0 is a very, very important. If you want to spend time to solve when 3 plus 6 cos theta equals 0, great. I'll just tell you right now, we don't set up the problem so that we'll have pi over 6's for cosine, because then you need a root 3 over 2. And it's not a nice equation to solve. So usually it's going to be at the half of the amplitude. So that's going to be at the pi over 3. This is 2 pi over 3 and 4 pi over 3. So those are important values, 2 pi over 3 and 4 pi. Cos theta equals -1/2. Theta equals 2 pi over 3 and 4 pi over 3. Those are important values, but like those are also in addition to our minimum and our midline. It's not our zeros, it's our midline. So we got max, midline. We got a 0 at 2 pi over 3. We got a min. We got a 0 at 4 pi over 3. We got a midline. We got a max. This represents the origin when r is 0. If we're going towards the origin, our value should be getting closer to 0. If we're going away from the origin, our value should be getting further away from 0. So, this is a horrible graph, but thank you. 0 to pi over 2. Positive values getting less positive. We are decreasing. We're going towards the origin. Pi over 2 to 2 pi over 3. Positive values getting less positive. We are decreasing. We're going toward the origin. 2 pi over 3 to pi. We have negative values getting more negative. Our radiuses are going away from 0. We are increasing. Even though our graph's going down, we are going away from the origin, where the origin is r equals 0. Then we go back towards. Distance is decreasing. And then we finish off with increasing. This could be 5, 5, 3, 2. Got it? Cool. We
It's asking how far it is. Don't ever look at the line.
Yeah, so now, for today's lesson, the graph isn't helping you get your answer. On the day 2 lesson, you were just like, oh yeah, it's going down. Radius is decreasing. But now it's like, whoa, yes, my radius is decreasing, getting closer to 0. But here, my radius is decreasing, getting further away from 0. If we are getting further away from 0, we're going away from the origin.
Are you going to make trick questions talking about like radius and distance on the test where it's like really carefully?
No. But we will challenge you with a question like this. This is like exactly as in the notes.
The AP test is like, it says you're decreasing, you have to like figure out which one it's talking about. Have you seen the AP test? No, yes.
Every question on your test have come from every AP College Board produced question. It's like, this is an example of a question that might be on the AP. Yeah, but once you throw all 11 units in the same test, it becomes something. Okay. This looks like brand new, and it's like, oh, Mr. Messer, I don't know how to, no, I don't know what to do here. Like, what, like, do I do my rectangle? We go back to, sometimes, our knowledge of
Theta equals 2, and theta equals 0, 6, theta equals 0.
Great. So this is important. When our angles are 0, 2, and 6, our radiuses will be 0. So those are very important values. So it's almost like I want the rectangular form of our x's and y's instead of our thetas and r's. But how do you graph x times x minus 2 times x minus 6?
You just skip the
0, 2, 6 are 0. What does it look like? You could do a sign chart. You could do that this is an x cubed with a positive leading coefficient. So your end behavior is here. You can look at your multiplicities. This is all review. But the only thing you're going to be challenged on is these aren't y's and x's. These are thetas when r is 0.
It's when it's like squared, it's the bump or something. Like the triple. So it's passed through bump.
You need to remember this,
A little
freshman, okay? Like,
2 is the bump and 1
if
is
you,
the pass.
you need to remember this.
Zero's
stuff.
an asymptote. Oh, no, it's odd. Yeah, when you do the lineup.
All right, answer the question.
3 is like.
Yes, even multiplicities like y equals x squared, bounce off and don't change signs at the 0. But now, answer the question. From 0 to 0.2, from 0 to 0.2, would the graph of r equals theta be going towards or away from the origin? From 0 to 0.2. Not from 0 to 2, from 0 to 0.2. Answer it. You could say the distance between the graph and the origin is increasing, or you could say it's going towards or away from the origin. It's the same answer. You tell me what's going on between 0 and 0.2. Yes. My radiuses are positive and going up. Right here is the interval from 0 to 0.2. My radiuses are positive and increasing. That means my distance is increasing. That means my graph is going away from the origin. I'm just being very specific. What about 2 to 2.1? My radiuses are negative and getting more negative. They are going away from r equals 0. My distance is also increasing. My graph is going away from the origin. What about 5.926? This is not 5 to 9.6. This is 5.926. Answer the question. Don't think this is going to come magically. You got it. 5.9 to 6. Tell your neighbors, what's the answer? Yes, my radiuses are getting closer to 0, so my distance is decreasing. I'm going towards. Got it? Cool. Now notice, we did not have to actually graph what the polar graph looks like. You are not going to have to be too worried about doing all of the steps, which is on page 2, of sketching a polar equation. We have one entire page on just sketching one polar equation. It's good to know how to do. But here's how it does look. Go to this page. This is literally on your test. This is literally from the College Board, where they're like, you know what, all of the steps, I know we're jumping around, but we're going to be okay. They won't say, hey, give me all the steps. They'll do like you did on the quiz today. Here's a graph. Which one of these equations produces that graph? There's like lots of different techniques to be able to get the right one. Here's a question. Hey, here is the rectangular form of some equation. Please pick out on your test, it'll be like, which one of these 4 graphs will be produced? Well, here, try to sketch this. You don't have to do everything. Let's just try to sketch this. Go. Again, this is an x and a y, which corresponds to an angle and a radius. Go. See if you can do it. Angle 0, radius 6. Please just start in the right spot. Angle 0, radius 6. Angle 2 pi over 3, radius 0. Here's the key, guys. Between 0 and 2 pi over 3, your radius needs to decrease. If you want to include something like pi over 3, we would have 2.5. And it would look something like that. Between 2 pi over 3 and pi, my radius will go from 0 to -2. So 0 to -2 ends up there. We need to stick our graph to be opposite of these angles, so we're looking at something like that. Pi to 4 pi over 3, pi to 4 pi over 3, my radius is -2 to 0. So we need to stay between these two angles, go from -2 to 0. Then from 4 pi over 3, we will be expanding our radius out, and we create this graph. Will you have to sketch it on the AP test? No, but you'll have to be able to pick out which one's which. Now, here comes another fun one. Try this one. We're doing our homework right now, so you might as well do it. Oh, I'll copy down cold trinkets later. What we will see is we will be starting to produce some different types of shapes. Shapes that we haven't seen yet, like 5 cos 2 theta. This is what 5 cos 2 theta looks like. Now, being able to create this exact sketch is not important, but it's important to see how it is made. What we are about to graph, what you're trying to graph, is an example of 5 cos 2 theta, or at least a portion of it. Watch. 0, 5, pi over 4, 0. In between 0 and pi over 4, my radius needs to decrease. Between pi over 4 and pi over 2, my radius will go from 0 to -5. Here's -5 at pi over 2, which means I need to be kind of in between here and there, going there. Then, when I get to 3 pi over 4, whose opposite angles over here, I need to get back to 0. And then from 3 pi over 4 to pi, I need to go to a radius of 5. We create this graph the following way. Start here, end here. We travel this way, and we actually cross kind of over ourselves as we're moving along. On the original graph. Well, guess what? If we kept going between pi and 5 pi over 4, I will have positive radiuses getting closer to 0. Between 5 pi over 4 and 3 pi over 2, here's your answer. Ready? Between 5 pi over 4 and 3 pi over 2, our radius is going to go negative. Between 5 pi over 4 and 3 pi over 2, this is that top. We don't get to create the top petal of the rows until we get all the way over here to these angles. And we're plotting the opposite radius. And then we come back in and we finish off between 7 pi over 4 and 2 pi. Watch how the graph is created. No, but you pick the right graph. Ready? Watch how it's created. Ready? Here we're at pi over 4. Here we're at pi over 2 negative. Here we are at 3 pi over 4 0. Here is where you stop at pi. Then after pi, we get to 5 pi over 4, 0, we'll get to 3 pi over 2, negative 5, we'll get to 7 pi over 4, 0, we'll get to 2 pi 5. It's not like pedal, 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 going around the circle. It's actually positive and negative radiuses, which create this design. And you will be tested on that the following way. Here we go. Here's 4 cos 2 theta. Which quadrant and between which points, we got A, B, C, D, and E, is the graph created from 3 pi over 4 to pi? For example, for the first question, between 0 and pi over 4, well, between 0 and pi over 4, we saw that we traveled from C to E, and we are in quadrant 1. Now, here's a hint. What's going to help you is the polar form. The rectangular form. Adjusting your period. Splitting that in half, realizing the pi over 4 being the important point. Going up to 4, hitting a midline, going down to negative 4. Positive 4, midline, negative 4, midline, positive 4. This is pi over 2. Okay? C, you can answer this. Between pi over 2 and 3 pi over 4, okay? Between pi over 2 and 3 pi over 4 is my rectangular graph. Where are we? What quadrants between what and what? Answer.
3.
Tell your neighbor.
B to E. Quadrant 3. 3 E to D. B to E. Quadrant to B. Quadrant 3.
No. Between pi over 2 and 3 pi over 4. You would think it's B to E, right, Colt Trickett? But from pi over 2 to 3 pi over 4, my radius is negative. From pi over 2 to 3 pi over 4, we actually have this portion of the graph, D to E, in quadrant 4. D to E, because we're talking about, wait.
I gotcha.
Yeah, we're talking about a radius of being negative 4 to a radius of 0. Okay, 3 pi over 4 to pi. Something, you got to tell me. 3 pi over 4 to pi. My radius goes from 0 to positive 4. Positive radiuses are easy. From 3 pi over 4 to pi, I'm going from a radius of 0 to a radius of positive 4.
E to A.
E to A, quadrant 2. Did you?
No. I had those 2 letters, man.
E to A, quadrant 2, not quadrant 3. Okay. Go. Next 2.
I understand what we're doing with the question, originally asking to find which one was from 40.
No. I'm giving you the answer to the first one so you understand.
Okay.
In case I didn't do this and you were trying to do this without the homework video, I was going to try to give you help.
Okay. Not here, here. It's the direction.
Negative pi would correspond to here. So I would kind of restart my graph over here at negative pi, going to negative pi over 2, passing over negative 3 pi over 4. Negative pi to negative 3 pi over 4 is actually this portion. Negative pi to negative 3 pi over 4. My radius is positive, so I'm A to E in quadrant 3. My radius is positive. From negative pi to negative 3 pi over 4, I'm just repeating this period. I'm going from a radius of 4 to a radius of 0. from negative pi to negative 3 pi over 4, I actually would have this piece. I would go from a radius of 4 to a radius of 0, positive 4 to 0, I'm a to e. Try the next one. Negative pi over 2 to negative pi over 4. What does that look like? Which quadrant? Tell your neighbors. A lot of you are like, I'm not sure. Some of you are just guessing.
One.
Negative pi over 2 to negative pi over 4. My radius goes from negative 4 to 0. From negative 4 to 0. But we're here. We are B to E. For which quadrant? 2. You got it. Okay, so this is the challenges guide. Now, one more question coming at you. We'll go right here, which will happen a lot. At what locations is the distance between the graph and the origin at a max?
The top of the parabola.
That's a great call. Okay, so here I got two. I'm going to do it for you. No, of course you do not have a calculator. I have two questions right here. They look like they're the same. Only one is different in that we have a -2 and this is a +2. Okay. Well, so my midline is 2. My midline is -2. My amplitude's 5. My amplitude being 5. My graph goes from a max, midline, min, midline, max, and my graph goes from a max to a midline to a min to a midline to a max. So I'm providing all the information you need to answer this question. And here's the question: when, what theta will the distance be a max from the origin?
It keeps going up. Or does it up? 2 pi n.
When the radius is +7, oh yeah, that looks like a max. Yeah, cool. So like 0 and 2 pi is the answer to this question. When the angle is 0 and the angle is 2 pi, I have that max distance, that maximum that we're talking about. And then we pop over here and we're like, well, it's the same graph, so it must be 0 and 2 pi, and you are wrong.
It's pi.
Why?
Because we started at 0.
Because when a radius is a large negative number, it is far away from the origin. This statement, maximum distance from the origin, does not mean it has to be a maximum R value. It could be a minimum R value. This answer is pi. You literally have gotten started on every single problem of your homework. Good. If you think that this is not hard, you are one of the few pre-calculus students I've ever taught that have thought that after this. I think it's because we changed it. Yes. Yo, he's trying to be like me. Barry, I'm honored. Don't say that. Don't say that. Don't say that.